Hi, I'm Frank Pierce of Richardson, Texas, USA. Recently I was advised of an experiment conducted by Mr. Martin Grusnick of Germany, in which he had taken a traditional Michelson-Morley interferometer, had tipped it on its side 90 degrees, and had reperformed the experiment in the vertical plane. Mr. Grusnick observed anomalous behavior of the fringe pattern during that 360-degree rotation. More specifically, he observed that through 180 degrees, approximately 12 fringe lines moved across the screen, and then they abruptly changed course, reversing themselves through the next 180-degree rotation, where another approximately 12 fringe lines moved in the opposite direction. Mr. Grusnick also observed that the beginning and ending points of this fringe shift occurred when the half-silvered beam splitter mirror was parallel to the Earth. Now, many people immediately seized upon that as proof of an ether, and in particular a vertical ether drift or a ether gradient. In fact, Mr. Grusnick finally came to the same conclusion. But many of us were skeptical of that result. I felt like it was strain induced by the gravitational effect on the components or on the baseboard during the vertical rotation. And so I set out to perform the experiment myself and to determine whether Mr. Grusnick's results were accurate. Now here we have the interferometer set up with a green 532 nanometer 5 milliwatt laser with a 3-volt battery pack, traditional half-silvered mirror beam splitter, and 2 fully adjustable end mirrors, and a plano convex diverging lens of 28 millimeters in focal length. Now all of these components have been epoxied and superglued to a 1-inch granite base plate, which is further securely glued to the rotating platform. Now you'll also notice 2 strips of duct tape. These are here only for security purposes in case the glue to the platform were to fail. Now in the beam splitter, you'll notice on each end that I have increased the structural support because the beam splitter is the most sensitive part of the interferometer. In fact, you'll see as I touch the beam splitter, and we'll go up and take a look at the fringe pattern, and you'll see that as I barely touch the beam splitter, we get a wild swing in the fringe pattern. Now it's here at the beam splitter where I believe the Grusnick effect originates. Now the interferometer is further mounted to a fully rotatable platform that can be tipped on its side 90 degrees for either horizontal or vertical rotation without changing any of the interferometer components. Now the platform also includes an onboard camera mount and the viewing screen for the interference pattern. Okay, we have the interferometer in the traditional horizontal plane. I'm going to rotate it 360 degrees, and let's view the interference pattern. Now we see there was no movement of the interference pattern that would be expected in view of the historical record of this type of experiment. Now let's go into the vertical plane. Okay, now the platform has been tipped 90 degrees on its side so that the interferometer is now ready for rotation in the vertical plane. We'll mount the onboard camera and we'll rotate the interferometer and we'll see the results. Okay, now we have the interferometer in the vertical orientation. Will get us a good fringe pattern. Now the viewing screen is horizontal to the surface of the Earth. Let's call that a 3 o'clock position. And I'm going to rotate the interferometer through 360 degrees. There's 90 degrees, 180, 270, and back to our 3 o'clock starting position. Now I'll do that one more time. Here we go through the 6 o'clock ground position, the 9 o'clock position, the 12 o'clock ceiling position, and back to our original 3 o'clock starting position. Now I'll reverse that, and we'll go backwards 360 degrees and see if there's any effect on the fringe pattern. And there we are, back to our starting point. Now, as you'll recall, in the Grusnik experiment, he observed that approximately 11.5 fringe lines moved across the screen for every 180 degrees of vertical rotation. He further observed that the beginning and reversal points of the fringe pattern shift occurred when the half-silvered mirror beam splitter was horizontal to the surface of the Earth. Now I'm going to duplicate Mr. Grusnik's setup, and here we have the half-silvered mirror horizontal to the surface of the Earth. This places the viewing screen in an approximate 8 o'clock position, and I'll rotate it through 180 degrees, and we'll see if there's any result. And there we are with 180 degrees, and we'll stop at the approximate 2 o'clock position. Now we'll continue for another 180 degrees. As you recall, Mr. Grusnik's observation was 11.5 fringe lines reversing in the opposite direction through this 180 degree turn. And now we're back to the original 8 o'clock position. You see some slight fringe motion, but nothing of that order observed by Mr. Grusnik. Now, I do believe that light is transmitted by a medium, most likely gravitational fields. For example, light emitted at or near the surface of the Earth is primarily transmitted by the terrestrial field, thus accounting for the null results of the experiments such as that conducted by Michelson-Morley. However, I don't believe that Mr. Grusnik has detected that field. I believe that his experimental results are artifacts of strain induced in the components and in the aluminum breadboard that he used for his interferometer setup. Now I want to thank Mr. Greg Volk for making me aware of Mr. Grusnik's experiment, Mr. Eckhard Preichschott for his unwavering encouragement and support for this experiment, Mr. Rafe Mikhail of Edmund Optics for his recommendations for the interferometer components. So I hope you enjoyed this video, and I wish you the best.